Hi guys, this is Sahiti on behalf of EduReka and I welcome you to this session on SQL interview questions. So in this session guys, we'll mainly focus on the top 65 interview questions generally asked about SQL. Now in the era of 2.5 quintillion bytes of data being generated every day, data plays a crucial role in decision making for business operation. This quite quintessentially makes us handle data in databases and gives us the need to use the database management systems. With various kinds of database management systems present in the market today, the relational database management system is one of the most popular systems available. Now, this type of database management system uses a structure that allows the users to identify and access data in relation to another piece of data in the database. And SQL is the core of relational database which is used for accessing and managing the database. So definitely knowing SQL will open the doors for you to become a database administrator. So guys, if you're preparing for interviews to become a database administrator, then SQL is one of the important skills that you need to master in. So with the note of this, let's just get started with the SQL interview question. So the first question that we have is, what is the difference between delete and truncate statements? So I'll start by explaining you what is the delete command. Well, the delete command is basically used to delete a row in the table. So you can also roll back data after using the delete statement, and it is a data manipulation command. Coming to the truncate statement is basically used to delete all the rows from a table, and you cannot roll back the data. This is a data definition language command, and it is faster than the delete command. So if anyone asks you the difference between the delete and the truncate statements, don't forget to mention that the truncate statement is definitely faster than the delete statement, and the truncate statement is from the data definition family and the delete statement is from the data manipulation family, right? Now moving on to our next question, that is, what are the different subsets of SQL? Well, the different subsets of SQL are mainly the data definition language, the data manipulation language, the data control language, and the transaction control language. Now coming to the data definition language, this set of language consists of the commands that can be used to define the database schema. So whenever you want to define the database schema, you can use the commands from this particular language. Coming to the data manipulation language, the manipulation language consists of all the commands that deal with the manipulation of data present in the database. So for example, if you have n number of tables and you want to manipulate the data present in those tables, then you use data manipulation commands. Coming to the data control language, the data control language includes the commands which deal with the write permissions and other controls of the database systems. So for example, you work for an enterprise and the enterprise has a database. Now obviously all the employees will not have the access to the database, right? So data control language mainly deals with how you give the user permissions to access to the database. Now coming to the last type of language, that is the transaction control language. This basically includes the commands which mainly deal with the transaction of the database. Whenever you want to roll back or you want to perform any various kind of transactions, then you use the set of commands from this language, right? So I hope I'm clear. So as I said, there are mainly 4 different subsets of SQL that you should mention. That is the data definition language, the data manipulation language, the data control language, and the transaction control language. Now moving on to our next question, that is, what do you mean by database management systems and what are the different types of it? So now if I have to define the database management system for you, then a database management system is a software application that interacts with the user's applications and the database itself to capture and analyze the data. So the data stored in a database can be modified, retrieved, and deleted and can be of any type like the strings, numbers, images, etc. So you can basically store any kind of data. Now the different kinds of database management systems are the hierarchical, the relational, the network, and the object-oriented database management systems. Now talking about the hierarchical database management systems, this type of database management system has a style of predecessor and the successor type of relationship. So it has a structure similar to that of a tree, wherein the nodes represent the records and the branches of the tree represent the fields. Coming to the relational database management system, this type of database management system uses a structure that allows the user to identify and access data in relation to another piece of data in the database. The network database management system supports many-to-many relations wherein multiple member records can be linked, and the object-oriented database management systems uses small individual softwares called objects, and each object contains a piece of data and the instructions for the actions to be done with the data. So I hope I'm clear with this point. So now moving on to our next question, that is, what do you mean by a table and a field in SQL? So now the answer to this question is quite simple. A table basically refers to a collection of data in an organized manner in forms of rows and columns, and a field refers to the number of columns in the table. If you have to explain anybody what a table and field mean, So basically in SQL, you have a database, and a database consists of n number of tables, right? So that is basically a table. And the tables have few column names, right? So the column names are basically the fields. So you can explain with an example, as you can see on the screen. So over here, I have an employee information table, into which the employee information table is a table, and the column names in this particular table are the fields. Now moving on to our next question, that is, what are joins in SQL? Now this is one of the most popular questions that is generally asked in your interviews. So basically a join clause is used to combine rows from two or more tables based on related columns between them. It is used to merge two tables or retrieve data from there. And there are mainly four types of joins in SQL. That is the inner join, the full join, the left join, and the right join, right? Now moving on to our next question. That is, what is the difference between char and varchar2 data type in SQL? Now, this is one of the most confusing questions that is generally asked in your interviews, since generally people get confused between what is char and what is varchar data type. Now, both char and varchar2 are used for character data type, but varchar2 is used for character strings of variable length, whereas the char is used for strings of fixed length. So whenever you have strings of fixed length, then you use the char data types, and whenever you have strings of variable length, then you can use the varchar2 data type. Now, for example, char 10 can only store 10 characters and will not be able to store a string of any other length, whereas the varchar2 10 can store any length, that is either 6, 2, 8. It completely depends on the variable, right? Now, moving on to our next question, that is, what is a primary key? Now, when you're working in a database field, obviously a company can have n number of databases having n number of tables inside it. Now, each and every table in a database has to be connected with the other table, right? Now for that, we need to uniquely identify a table, or you can say you need to uniquely identify a column. So basically, primary key is a set of attributes that can be used to uniquely identify every tuple. So if there are around 3 to 4 candidate keys present in a relationship, then out of those, one can be chosen as the primary key. Now, as you can see on the screen, we have an employee information table which has columns like employee number, employee name, employee country, and the employee age. Now, obviously, you can uniquely identify each and every employee with the employee ID, right? So basically, that will be our primary key. So over here, employee number will be a primary key. Now let's move on to our next question, that is, what are constraints? So constraints are basically used to specify the limit of the data type of the table, right? So whenever you're creating a table, then you can use the constraints to set a limit of the data type of the table. It can be either specified while either creating the table or while you're altering the table statements. So it can be basically specified in both the ways. Now there are mainly 5 constraints that you need to understand about. That is the not null constraint, the unique constraint, the check constraint, the default constraint, and the index constraint. Now the not null constraint basically ensures that a null value cannot be stored in a column. So whenever you mention this particular constraint into a column of your table, then this particular constraint will make sure that no null value can be stored for that particular column in the table. Moving on to the next constraint, that is the unique constraint. This constraint makes sure that all the values in the column are basically different. So if you need to make sure that in a column you have unique values for each and every row, then you can use this particular constraint. Now moving on to the next constraint, that is the check constraint. The check constraint basically ensures that all the values in a column satisfy a specific condition. So if you have a condition and you need to make sure that only the values which satisfy the condition are stored in the column, then you can use this particular constraint. Now talking about the default constraint consists of a set of default values for a column when no value is specified. So for example, in a table of 10 rows, you have a column in which you do not specify all the values for all the 10 rows. Then you can make sure that you have set a default value, and the default value will be automatically stored whenever you don't mention a value in that column. Now moving on to the last type of constraint, that is the index constraint. The index constraint is used to create and retrieve data from the databases very quickly. So I hope I'm clear with the different types of constraints that you need to answer about when you're asked this question about what are the constraints that you know. Now let's move on to the next question, that is, what is the difference between SQL and MySQL? Now this is one of the most popular questions that is generally asked, because since people generally get confused between what is SQL and what is MySQL. So let me just explain you the simple difference between both of them. So SQL is basically a standard language which stands for Structured Query Language based on the English language, whereas the MySQL is a database management system. So SQL is basically the core of relational database which is used for accessing and managing the database, whereas MySQL is a relational database management system which works on many platforms. So basically this provides multi-user access to support many storage engines and is backed by Oracle. So that's the basic difference between SQL and MySQL, guys. SQL is basically the core of relational database, which is used for accessing and managing a database. And MySQL is an open source relational database management system. Now let's move forward to our next question. That is, what is a unique key? Now, unique key basically identifies a single row in a table. This basically allows multiple values per table, and also the null values are allowed. So you'll have to make sure that, whenever you're using the unique key, you need to have an idea that, it identifies a single row in the table. Multiple values are allowed per the table, and also null values are allowed, but yes, duplicate values are not allowed. All right. Now moving forward to our next question, that is, what is a foreign key? A foreign key basically maintains referential integrity by enforcing a link between the data in two tables. The foreign key in the child table references the primary key in the parent table, and the foreign key constraint prevents actions that would destroy the links between the child and the parent table. So if you have a database and if you have around 10 tables in that particular database, and then if you want to maintain relations between all these tables in the database, then you need to use the primary key foreign key concept so that you identify the relation between both these tables with the help of foreign key. Now moving forward to our next question, that is, what do you mean by data integrity? Now, data integrity basically defines the accuracy of the data as well as the consistency of data stored in the database. It also defines the integrity constraints to enforce business rules on the data when it is entered into an application or a database. So if you have to answer this question, then you can answer by saying that, data integrity basically defines the accuracy and the consistency of data. Now let's move forward to our next question. That is, what is the difference between the clustered and the non-clustered index in SQL? The clustered index is basically used for the easy retrieval of the data from the database and is faster than the non-clustered index. The clustered index alters the way records are stored in the database as it sorts out the rows by column, which is said to be the clustered index, and only one table can have a clustered index. Coming to the non-clustered index, the non-clustered index is also used for the retrieval of data from the database, but yes, it is slower than the clustered index. The non-clustered index does not alter the way it is stored, but yet it creates a separate object within a table which points back to the original table rows after searching. And also, one table can have many non-clustered indexes. The main difference between both of them are both are used for easy retrieval of data, but yes, the clustered index is faster than the non-clustered index, and only one table can have only one clustered index, but yes, a single table can have many non-clustered indexes. Apart from that, the third difference between both of them is also that the clustered index alters the way records are stored in the table, and the non-clustered index does not do that. Now let's move forward to our next question, that is, write a SQL query to display the current date. Now when you attend the interviews for a database administrator, let me just tell you that not only the theoretical questions are asked, but yes, you're sometimes asked to write the queries also. So they can give you some scenario based questions, or they can just ask you a few simple queries that you need to make sure that you know that. So that's the reason that this question could be asked, that write a SQL query to display the current date. Now in SQL, to display the current date, we have a function known as the getDate. So basically, with the help of this function, you can return the current date and timestamp. So the syntax of the function is really simple. It's just getDate, and it applies to SQL Server 2017, 16, 14, 12, 2008, R2, 2008, and 2005. Now, if you just have to give an example to the interviewer about how to write a query to display the current date, you can just mention the query like, select get date. So when you execute this particular query, you would see an output that, the current date and time would be displayed as out, right? So that's how you can write a query to display the current date. Now, moving forward to the next question, that is, what are the different types of joins? So as I mentioned before, there are mainly 4 types of joins that you need to talk about. That is the inner join, the full join, the left join, and the right join. So talking about the inner join, this join basically returns those records which have matching values in both the tables. Now consider 2 tables, table A and table B. Now when you apply the inner join on both of these tables, you'll observe that the output would be all those records which have matching values in both the tables, that is table A and table B. Now talking about the full join basically returns all those records which either have a matching value in the left or the right table. So whenever you apply full join on both of these tables, you'll see that you'll get an output of all those records which either have a match in the left or the right table. Now talking about the left join returns the records from the left table and also those records which satisfy the condition from the right table. So if you have table A and table B and you apply a left join to both of these tables, then the output would be all those records from the left table and the records from the right table which satisfy the specified condition. Similarly, the right join is just the vice versa. The right join basically returns the records from the right table and also those records which satisfy the condition from the left table. So whenever you apply the right join to table A and table B and consider that the table B is right table, you'll get all those records from the table B and also matching records from table A which satisfy the condition. So these are the various types of joins that you need to talk about, guys. Now moving forward to the next question, that is, what do you mean by denormalization? Now, denormalization basically refers to a technique which is used to access the data from higher to lower forms of database. It increases the performance of the entire infrastructure as it introduces redundancy into the table, and it also adds the redundant data into a table by incorporating database queries that combine data from various tables in a single table. So if you have to just explain denormalization, you can just say that it is a technique which is used to access data from higher to lower forms of database, and it basically adds redundant data into the table by incorporating database queries that combine data from various tables. So I hope I'm clear with this point. Now moving forward to the next question, that is, what are the entities and relationships? So let me just explain you what entities are first. So entities can be anything like a person, place, or a thing in real world about which data can be stored in a database. So tables store data that represent one type of entity. So for example, a blank database has a customer tables to store the customer information. Now the customer table stores this information as a set of attributes, that is basically the columns within the table for each and every customer. So if you consider, a customer table has around 5 parameters like customer ID, customer name, customer phone number, customer email ID, and so on. Then all these customer ID, customer name, customer phone number are basically the column names, that is the attributes for the entities, and customer information will be the entity. Now talking about relationships, relational links between the entities that have something to do with each other is basically relationships. So for example, the customer name is related to the customer account number and the contact information, right? Now this might be in the same table or it could be in any other table also, right? So if you have two tables out of which one table has the customer name and the other table has all the other information like the customer ID, customer name, and so on. Now these two tables will be related to each other with a relationship so that the customer details could be retrieved. Now that particular information is basically relationships. Now moving forward to our next question, that is, what is an index? In the previous questions, I talked about the non-clustered index and the clustered indexes, right? But what exactly is an index? Now, index basically refers to a performance tuning method of allowing faster retrieval of records from the table. So as I mentioned before in the clustered and the non-clustered indexes question, both of the indexes are basically used for easy retrieval of data, right? So that's what an index does. This is basically a performance tuning method to allow faster retrieval of data from the table. And also an index creates an entry for each value. So to allow the faster retrieval of records from the table, it basically creates an entry for each and every value. Now let's move forward to the different types of indexes. So well, I've already explained you about two types of indexes, that is the clustered and the non-clustered index. But yes, let's understand again about both of them and also an additional index, that is the unique index. So mainly there are three types of indexes that is used, that is the unique index, the clustered index, and the non-clustered index. The unique index basically does not allow the field to have duplicate values if the column is unique indexed. So if a primary key is defined, a unique index can be applied automatically. So unique index is mainly used when you do not want any duplicate values to be present in the column. Now moving to the clustered index, the clustered index basically reorders the physical order of the table and searches based on the basis of key values. So each table can have only one clustered index. Coming to the third type of index, that is the non-clustered index. The non-clustered index does not alter the physical order of the table and maintains a logical order of the data. So each table can have many non-clustered indexes, right? So basically, guys, there are three types of indexes that you need to explain about. That is the unique, the clustered, and the non-clustered index. Now moving forward to our next question, that is, what is normalization and what are its advantages? So normalization is basically the process of organizing data to avoid duplication and redundancy. So it's basically the opposite of denormalization that we just talked about in one of the previous questions. So if you just have to define normalization, then you can say that it is a process of organizing data to avoid duplication and redundancy. Now the advantages of normalization are, as you can see on the screen. It offers better database organization, more tables with smaller rows, efficient data access, greater flexibility for queries, quickly finds the information, easier to implement security, allows easy modification, reduction of redundant data and duplicate data, more compact database, and ensures consistent data after modification. So guys, these are few advantages of normalization. Now let's move forward to our next question, that is, what is the difference between the drop and the truncate commands? The drop command basically removes the table and it cannot be rolled back from the database. Whenever you use the drop command, just remember that you completely drop the complete table and it cannot be rolled back from the database. And the truncate command removes all the rows from the table and also cannot be rolled back into the database. So the drop command and the truncate command differ by this. So whenever you use the drop command, you drop the complete table, and whenever you will use the truncate command, you will remove all the rows from the table. The syntax of both the commands are almost same. The syntax of drop command is basically drop object and object name, that is basically the table and table name. And the syntax for truncate command is truncate table and table name. So guys, that was about the drop and the truncate command. Now let's move forward to the next question, that is, what are the different types of normalization? So there are mainly four types of normalizations, that is 1NF, 2NF, 3NF and BCNF. Now let me explain you the different types of normalization with an example. So guys, this is the table that we're going to consider for the example. Now you basically have to apply normalization to this particular table. Now to apply normalization to this particular table, you'll clearly observe that there is Alice Johnson who has a particular address and has rented few movies from a specific category, and the category action is mentioned twice over here. Similarly, David Allen's address has been divided into two different records, and the movies rented and the categories have also been divided into two different records, right? Now to apply normalization to this particular table, you first have to apply the 1NF, that is the first normalized form. So for a table to be in 1NF, you need to make sure that each table cell should have a single value. So basically all the records must be unique. So as you saw in this particular table, we had redundant values in the same record, right? So we're going to have each cell with a unique record. So we'll have records such as, Miss Alice Johnson, First Street, house number 3, Mission Impossible, and the second record as Miss Alice Johnson, First Street, house number 3, Clash of Titans. Similarly, we'll have Mr. David Allen, 3rd Street, 45 with Interstellar, Mr. David Allen, 3rd Street, 45 with Edge of Tomorrow, and similarly, Mr. David Allen, 7th NU, Mission Impossible Fallout. So that's how basically you get your table into 1NF. You have records with unique value in the complete table. Now, as you can see on the screen, this is our table for 1NF. Now, you have to divide this table to 2NF. So when I say 2NF, that is the second normalized form, you can divide this table into two different tables. So to have a table in 2NF, you need to make sure that the database should be in 1NF and should also have a single column primary key. Since our table is in 1NF that we considered, that's applicable to our situation. Now let's move forward to the 2NF. Now in the 2NF, you'll clearly see that we have salutation, full name, address and movies rented, right? Now to divide this table into two different tables, you can clearly see that I've added an ID to both the tables. So I've added ID, salutation, full name and address, and ID, movies rented. So Miss Alice Johnson, staying in First Street, house number 3, must have rented Mission Impossible. Similarly, she must have rented Clash of Titans. Mr. David Allen, staying in 3rd Street, 45, has rented Interstellar and Edge of Tomorrow. And Mr. David Allen, staying in 7th Avenue, has rented Mission Impossible Fallout. So that's how I've divided the table into 2NF. Now moving forward to 3NF. Now a database to be in 3NF, you need to make sure that your database is first in 2NF and must not have any transitive functional dependencies. So for that, what you're going to do is you're going to further divide the two tables into three tables, as you can see in the screen. So we're going to have an ID, full name, address and salutation ID, and also another table with ID, movies rented, column attributes, and the third table with salutation ID and salutation. So basically, we're going to identify Mr. with 1, Miss with 2, Mrs. with 3, and Doctor with 4. So that's how we're going to get our tables to 3NF. Well, guys, with this, we come to an end of this particular example that, our table has been completely normalized and the highest normal form available for this particular table is 3NF. Now, moving forward to the final type of normalization, that is BCNF. Now, if your database is in third normal form and there would be some scenarios where anomalies would be present, and if you have more than one candidate key, then BCNF comes into role when you further divide your table so that there would be only one candidate key present. So guys, these are the various types of normalization, that is 1NF, 2NF, 3NF and BCNF. So in 1NF, there is no repeating groups within the rows. In 2NF, every non-key column is dependent on a whole primary key. In 3NF, it is completely dependent on the primary key and no other non-key column values. And in BCNF, you have to make sure that there's only one candidate key present in the table. So guys, these were the different types of normalizations that you need to understand about. Now let's move forward to our next question, that is, what is asset property in database? The asset property mainly stands for atomicity, consistency, isolation, and durability. It is basically used to ensure that the data transactions are processed reliably in a database system. So if you have to define asset property in a database, then you have to define all these terms individually. A stands for atomicity. So atomicity refers to the transactions that are completely done or failed, where transaction refers to a single logic operation of a data. It means if one part of any transaction fails, then the entire transaction fails and the database state is left unchanged. Coming to consistency, consistency ensures that the data must meet all the validation rules. In simple words, you can say that your transaction never leaves the database without completing its state. Third part, that is isolation. The main goal of isolation is the concurrency control. And the last part, that is durability. Durability means that if a transaction has been committed, it will occur whatever may come in between, such as power loss, crash, or any sort of error. Now let's move forward to our next question, that is, what do you mean by a trigger in SQL? So triggers in SQL are a special type of stored procedures that are defined to execute automatically in place or after data modifications. It allows you to execute a batch of code when an insert, update, or any other query is executed against a specific table. So guys, there are mainly 6 types of triggers that you need to understand about. That's the before insert, before update, before delete, and after delete. So basically the two main key terms that you need to understand are the before and the after. So these are completely applied on the insert, update, and the delete commands. The before insert is basically activated before the data is inserted into the table. The after insert is activated after the data is inserted into the table. The before update is activated before the data in the table is updated, and the after update is activated after the data in table is updated. The before delete is activated before data is removed from the table, and after delete is activated after the data is removed from the table. So guys, this is what a trigger in SQL is. It is basically a type of stored procedures that is defined to execute automatically in place or after data modifications. Now let's move forward to our next question, that is, what are the different types of operators available in SQL? So there are mainly 5 types of operators available in SQL. That is the arithmetic, bitwise, comparison, compound, and the logical operators. So guys, these are the main 5 types of operators available in SQL. So now let's move forward to our next question, that is, are null values same as that of 0 or a blank space? A null value is not at all same as that of a 0 or a blank space. A null value mainly represents a value which is unavailable, unknown, assigned, or not applicable, whereas a 0 is a number and a blank space is a character. So if anybody asks you if null values are same as that of 0 or blank space, please say it's no. Because the null values is basically anything which is unavailable, unknown, and is assigned or not applicable, whereas a 0 is a number and a blank space is a character. Now let's move forward to our next question, that is, what is the difference between a cross join and a natural join? The cross join produces the cross product or Cartesian product of two tables, whereas the natural join is based on all the columns having the same name and data types in both the tables. The main difference between both of them is that the cross join basically produces the cross product of both the tables, and the natural join is completely based on all the columns having the same name, data types in both the tables. Now let's move forward to our next question, that is, what is a subquery in SQL? A subquery is basically a query inside another query, where a query is defined to retrieve data or information back from the database. So subqueries are always executed first, and the result of the subquery is passed on to the main query. So as you can see on my screen, I have an outer query inside which I have a subquery or an inner query. So basically this query is assigned to retrieve data from the database, and then this query will be executed first. So if there are any errors in this query, then the complete query would not be executed. Only when the subquery is completely executed, then the outer query will be executed. Now let's move forward to our next question, that is, what are the different types of subquery? Now there are mainly 2 types of subqueries, that is the correlated and the non-correlated subquery. The correlated subqueries are basically those queries which select the data from a table referenced in the outer query. It is not considered as an independent query, as it refers to another table and refers to column in a table. The non-correlated subquery is an independent query where the output of the subquery is substituted in the main query. So you'll have to understand the difference between both of them. If you do not understand by definition, you can definitely go and execute the commands, write the 2 different types of queries in your SQL, and you'll get to know what I'm talking about. Basically, non-correlated type of subquery, the output of the subquery will be substituted into the main query. And in correlated type of subquery, the queries select the data from a reference table in the outer query. Now let's move forward to our next question, that is, can you list the ways to get the count of records in a table? Now to count the number of records in a table, you can use various kind of queries. So there are mainly three queries that I've mentioned over here, that is select star from table 1. Star means basically select all, right? When you want to select all the rows, all the records from a table, you can use star. Next, when I say select count star from table 1, that is basically you select all the records from the table 1 and then you count them. And coming to the third query, that is select rows from system indexes where ID, object ID of table 1 and indeed is less than 2. That means it basically counts the number of records in a table with system indexes. These are the various ways to count the number of records in a table. Now let's move forward to our next question, that is write a SQL query to find the names of employees that begin with the alphabet A. Now to display the name of employees that begin with A, you can type in the command like select star from table name where you mention your table name, where employee name, because I'm considering an employee table in the scenario, like A% in quotes. So when I say A%, all those names starting with A and having any letters or any characters after that would be selected. So guys, that's how you can write a query to find the name of employees that begin with A. Now suppose if you want to write a query to find the names of employees that end with A, what you can simply do is you can again write the similar query like select star from table name where employee name like percentage A, right? So where the percentage comes forward, that means all the names that start with any alphabet but end with the A will be considered. Now let's move forward to our next question, that is write a SQL query to get the third highest salary of an employee from an employee table. Now to get the third highest salary of an employee from an employee table, you can write a query as you can see on the screen. You can just mention select top 1 salary from and then write a subquery which says select top 3 salary from employee table, order by salary in a descending order as emp, and then again order by salary in ascending order for the outer query. So you can write a query like this, guys. Now let's move forward to our next question, that is what is the need of group functions in SQL? Now group functions work on a set of rows and return one result per group. So basically some of the most commonly used group functions are the average, count, max, min, sum and variance. So when you say what is the need of group functions in SQL, the need is basically because the group functions work on a set of row and return one result per group. Now let's move forward to our next question, that is what is a relationship and what are the different types of relationship? So relation or links between entities that have something to do with each other can be basically termed as relationships. So relationships can be also defined as the connection between the tables in a database, right? Now the different types of relationships are the one-to-one relationship, the one-to-many relationship, many-to-one relationship, and the self-referencing relationship. When you have a relationship between two tables, that is table A and table B. So when I say one-to-one relationship between both the tables, table A and table B, a single record in table A will be related to a single record in table B. Coming to one-to-many relationship, a single record in table A can be related to many records in table B. Next, coming to the many-to-one relationship, many records in table A can be related to one record in table B. Coming to self-referencing relationship, the self-referencing relationship basically means that you can have a single table out of which two columns are related to each other with a relationship. Now let's move forward to our next question, that is how can you insert null values in a column while inserting data? Now to insert null values in a column while inserting the data, you mainly have two ways. That is either by implicitly by omitting columns from a column list or explicitly by specifying null keyword in the values clause. So guys, these are the two ways through which you can insert null values in a column while inserting the data. Now let's move forward to the next question, that is what is the difference between the between and the in condition operators? The between operator is basically used to display rows based on a range of values in a row, whereas the in condition operator is used to check for values contained in a specific set of values. So if you have to explain with an example for between and the in condition operators, then you can use the example on the screen. You can just write a query like select star from students where roll number between 10 to 50. So all those records from the students table would be selected whose roll number stands between 10 to 50. Coming to the in condition operators, you can use a query like this, like select star from students where roll number in 8, 15, 25. So all those records from a student table would be selected where the roll number would be either 8, 15 or 25. So guys, that is the main difference between the between and the in condition operators. Now let's move forward to our next question, that is, why are the SQL functions used? The SQL functions are used to perform some calculations on the data, to modify individual data items, to manipulate the output, to format dates and numbers, and also to convert the data types. So if you want to perform these activities, or if you want to perform these actions, then you need to use the SQL functions. Now let's move forward to our next question, that is, what is the need of merge statement? This statement is basically used to allow conditional update or insertion of data into a table. So it performs an update if a row exists or an insert if the row doesn't exist. So basically the need of merge statement is that it allows conditional update or insertion of data into a table. Now let's move forward to our next question, that is, what do you mean by recursive stored procedure? Recursive stored procedures refers to a stored procedure which calls by itself until it reaches some boundary condition. This recursive function or a procedure helps the programmers to use the same set of code n number of times. So basically you'll first mention the boundary condition and then you'll use the recursive stored procedure to check if it calls by itself till it reaches the specified boundary condition. Now let's move forward to our next question, that is, what is a clause in SQL? Now, SQL clauses basically helps you to limit the result set by providing a condition to the query. A clause helps to filter the rows from the entire set of records. So for your better understanding, the example is basically where and having clauses. So when you write a query having these two particular clauses, you basically mention a condition into these particular clauses, right? Like where student number is equal to 2 or having, roll number greater than 5 and so on, right? So that's how you can use a clause in SQL. Now let's move forward to our next question, that is, what is the difference between the having clause and the where clause? Now the main difference between having clause and where clause is basically that the having clause can be only used with the select statement. It is usually used by the group by clause, and whenever group by is not used, having basically behaves like a where clause. Coming to the where clause, the where clause is applied to each row before they are a part of the group by function in a query. So having clause is basically used with the select statement and it is usually used in the group by clause. When the having clause is not used with the group by clause, the having clause behaves like a where clause. So guys, that was about the difference between the having clause and the where clause. Now let's move forward to our next question, that is, list the ways in which dynamic SQL can be executed. The ways in which dynamic SQL can be executed are by writing a query with parameters, using exec, and by using sp-execute SQL. So there are basically three ways in which dynamic SQL can be executed. That is by writing query with parameters, using exec, and using sp-execute SQL. Now moving forward to the next question, that is, what are the various levels of constraints? Now constraints, as I mentioned before, are basically the representation of a column to enforce data entity and consistency. So mainly there are two levels of constraints, that is the column level constraint and the table level constraint. Now let's move forward to our next question, that is, how can you fetch common records from two tables? Well, you can fetch common records from two tables by using the intersect statement. So the syntax of intersect statement is, as you can see on the screen, it's basically select column 1, column 2 and so many columns from the table name where condition, basically you mention the condition over here, then you mention the keyword intersect and then again mention another table name, right? So that is again you mention select the columns from a specific table where the condition matches. So that's how you use the intersect command. So for your better understanding, you can see the example on the screen. You can see, that I have used select student ID, that is basically a single column from student, then use the intersect command, and then again I've mentioned select student ID from a different table, that is exam. So that's how you can fetch common records from two tables. Now let's move forward to our next question, that is, list some case manipulation functions in SQL. So there are mainly three case manipulation functions in SQL, that is the lower, upper, and the init cap. Now talking about the lower function, this function basically returns the string in lowercase. It takes a string as an argument and returns it by converting into a lowercase. The syntax of this particular function is basically lower, and in brackets you mention strings in quotes. Now moving forward to the next function, that is the upper function. This function returns the string in uppercase. It takes a string as an argument and returns it by converting it into an uppercase, right? So the syntax for this particular function is upper, and in brackets you mention the string within the quotes. Moving forward to the third function, that is the init cap. This function returns the string with the first letter in uppercase and the rest of the letters in lowercase. So the syntax for this function is basically init cap, and in brackets you mention the string with quotes. So guys, these were the three case manipulation functions in SQL. Now let's move forward to our next question, that is, what are the different set operators available in SQL? So the different set operators available in SQL are union, intersect, and the minus operators. So let's talk about union first. So when you consider two queries, that is the left query and the right query, and you apply the union operation, you will see that it will combine rows from both those queries. You'll get an output of all those records from the left table, that is basically the left query, and also from the right query, that is the right table. Moving forward to the next operation, that is the intersect operation. So when you apply the intersect operation to the left query and the right query, you'll see that you'll get only those rows which are common in both the queries, right? So for example, you have 10 rows in the first table and 10 rows in the second table, but the common rows in both these tables are just two rows. So you'll get only those two rows as an output to this particular operation. Moving forward to the third type of operation, that is the minus operation. So when you apply left query minus right query, you'll see that you'll get only those rows from the left query which are not included in the right query as an output. And when you apply the operation of right query minus left query, you'll see that you'll get only those rows as an output from the right query which are not included in the left query. So guys, these were the different set operators available in SQL. That is the union operator, the intersect operator, and the minus operator. Now let's move forward to our next question, that is, what is an alias command? Now, alias name can be given to any table or any column. So this alias name can be referred in where clause to identify a particular table or a column. So that's basically an alias command. So for example, if you see on the screen, you see a query, right? Like select m.employee.id department.result from employee emp, department as dep, where m.employee.id is equal to department.employee.id. So what I've given over here is that I've given an alias name to the employee table as m, and for the department table, I've given an alias name as dept. So that's how you can use the alias command, guys. Let's move forward to the next question now. That is, what are aggregate and scalar functions? The aggregate functions are used to evaluate mathematical calculation and return a single value. These calculations are done from columns in a table. So for example, if you need to consider the aggregate functions, then you can consider the max function and the count function as an aggregate function. Now coming to the scalar functions basically return a single value based on the input value. So if you need an example for scalar functions, then you can consider the u, case, and now as scalar functions, as they're calculated with respect to the string. So guys, this is what aggregate functions and scalar functions mean. Let's move forward to the next question, that is, how can you fetch alternate records from a table? When you answer this question of how you can fetch alternate records from a table, please make sure that you mention a point that you can fetch alternate records, that is both the odd and the even row numbers. Now to display the even row numbers, you can use the command like select student ID from select row number, student ID from student again, where mod row number comma 2 equal to 0. So we're using this function of where mod row number comma 2 equal to 0, right? So when you divide the row number with 2, and if you get the remainder as 0, then that particular row number would be an even number. And similarly, if you get a remainder as 1, then that particular row number would be an odd number. That's how you can segregate the alternate records, that is the even number records and the odd number records. You just have to mention the condition mod row number comma 2 equal to 0 for even, and mod row number comma 2 equal to 1 for odd. Now let's move forward to the next question, that is, name the operator which is used in query for pattern matching. The operator which is used in the query for pattern matching is basically the like operator. So in like operator, you can use either the percentage sign or the underscore sign. The percentage sign basically matches to 0 or more characters. If you use the percentage sign in the query, like select star from students where student name like a percentage, so all those student names whose name starts with A and ends with any character will be taken into account, and all the information related to all those records will be retrieved. And coming to when you use the underscore sign basically matches exactly one character. So when you use the underscore sign in the query, like select star from student where student name like ABC underscore, so all those records, whose student name has a characters which match the pattern ABC, and any character present after that will be taken into account. So guys, that's how you can use the like operator for pattern matching. You can either use the percentage sign with it or an underscore sign with it. Now let's move forward to the next question, that is, how can you select unique records from a table? Well, you can select unique records from a table by using the distinct keyword. So for your better understanding, you can write a query like select distinct student ID from student, right? So with the help of this query, all the unique records from the student table will be selected. Let's move forward with the next question, that is, how can you fetch first 5 characters of a string? Now there are obviously a lot of ways to fetch the characters from a string. So for your understanding, I've mentioned two examples over here. That is, either you can use the substring command or the write command. So when you use the substring statement, you can use the statement like, select substring student name 1 to 5 as student name from student. The first 5 characters of student name will be retrieved from the student table. Now similarly, when you use the write statement, you can use the statement like, select write student name comma 5 as student name from student, right? So with this query, again, all the first 5 characters of each and every student name from the student table would be retrieved. So that's how, guys, you can fetch the first 5 characters of a string. That is either by using the substring statement or the write statement. Now let's move forward with the next question. That is, what is the main difference between SQL and PL/SQL? Now, SQL, as I mentioned before, is a query language that allows you to issue a single query or execute a single insert, update, delete, whereas PL/SQL, that is basically Oracle's procedural language SQL, allows you to write a full program of loops, variables, etc. to accomplish multiple operations such as select, inserts, updates, and deletes. So guys, that is the main difference between SQL and procedural language SQL. In SQL, you just have to write a single query to execute, insert, update, and delete. And in procedural language SQL, you have to write full program with loops and variables to perform multiple operations like insert, update, delete, and select. Now let's move forward to our next question, that is, what is a view? A view is basically a virtual table which consists of a subset of data contained in a table. Since views are not present, it takes less space to store, and views can have data of one or more tables combined based on the relationship. So as you can see on the screen, I have two tables of n number of rows and columns. Now once I execute a query to form a view, you can clearly see that it has combined the columns and the rows from both the tables and has created a view of both of these tables into a single table. That's what a view is. Now let's move forward to the next question, that is, what are views used for? So views, as I just explained, basically refer to a logical snapshot based on a table or on any other view. It is used for restricting the access to data, making complex queries simple, ensuring data independence, and also providing the different views of the same data. So that's what views are used for. Now let's move forward with the next question, that is, what is a stored procedure? A stored procedure is basically a function which consists of many SQL statements to access the database system. Several SQL statements are consolidated into a stored procedure and are executed whenever and wherever required, which obviously saves time and we can avoid writing code again and again. So with the help of stored procedure, you can make sure that several SQL statements are executed again and again, and you don't have to write the query for it again, because if you just have a stored procedure for it, it will automatically execute the queries for you. Now let's move forward with the next question, that is, list some advantages and disadvantages of stored procedure. Let's talk about the advantages first. So stored procedure can be used as a modular programming, which means create one, store, and call for several times whenever it is required. This supports faster execution, and it also reduces network traffic, which provides better security to the data. Coming to the disadvantages of stored procedure, the only disadvantage of stored procedure is that it can be executed only in the database and utilizes more memory in the database server. So guys, that was about the advantages and disadvantages of stored procedures. Now let's move forward with the next question, that is, list all types of the user defined functions. So there are mainly 3 types of user defined functions, that is the scalar functions, the inline table valued functions, and the multi-statement valued functions. So you mainly have to mention these 3 functions when you're asked about the different types of user defined functions. Next, let's move forward and understand what do you mean by collation. So collation is defined as a set of rules that determine how data can be sorted as well as compared. So character data is sorted using the rules that define the correct character sequence along with the options for specifying case sensitivity, character width, and etc. So that's what a collation is, guys. It is basically a set of rules that determine how data can be sorted as well as compared. Now let's move forward with the next question, that is, what are the different types of collation sensitivity? So the different types of collation sensitivity are the case sensitivity, the kana sensitivity, the width sensitivity, and the accent sensitivity. So guys, these are the mainly 4 types of sensitivities of collation. So I hope that you've understood till now. Next in this session, let's understand what are the local and the global variables. Now talking about local variables first, these variables can be only used or exist only inside the function. These variables are not used or can't be referred by any other function, right? So whenever you want to use local variables, then you need to understand the fact that they can be only used or exist inside a single function, and they can't be referred by any other function. Coming to global variables, these variables are the variables which can be accessed throughout the program. So global variables cannot be created whenever the function is called, but yes, they can be accessed throughout the program. So guys, that was about the local and the global variables. Next, let's move forward and understand what is auto increment in SQL. Auto increment keyword allows the users to create a unique number to get generated whenever a new record is inserted into the table. So this keyword is usually required whenever primary key is used, and auto increment keyword can be only used in Oracle, whereas the identity keyword can be used in the SQL Server. So that was about auto increment in SQL, guys. Next, let's understand what is a data warehouse. Data warehouse refers to a central repository of data where the data is assembled from multiple sources of information. Those data are consolidated, transformed, and made available for the mining as well as the online processing. Warehouse data also has a subset of data called the data mart. So data warehouse can be understood as a central repository of data where the data is assembled from multiple sources of information. So guys, that was about data warehouse. Now let's move forward and understand what are the different authentication modes in SQL Server and how it can be changed. The different authentication modes in SQL Server are basically the Windows mode and the mixed mode. So these two modes are basically used in SQL Windows. And to change the authentication modes in SQL Server, what you can simply do is you have to follow the steps that I've mentioned on the screen. That is, you have to first click on Start, then go to Programs and go to the Microsoft SQL Server and click SQL Enterprise Manager to run SQL Enterprise Manager from the Microsoft SQL Server program group. Now to change the authentication modes in the SQL Server, you can follow the steps that I've mentioned on the screen. That is, you have to click on Start, go to Programs, go to Microsoft SQL Server, and click SQL Enterprise Manager to run SQL Enterprise Manager from the Microsoft SQL Server program group. Then select the server from the Tools menu and select SQL Server Configuration Properties and choose the Security page, right? So that's how you can change the authentication mode in the SQL Server, guys. Now let's move forward with the final question in this session. That is, what are stuff and replace function? So talking about the stuff function first, this function is basically used to overwrite existing characters or insert a string into another string. So the syntax for this function is basically stuff, string expression, start, length, and replacement characters, where the string expression is basically the string that will have characters substituted. Start represents the starting position. The length refers to the number of characters in the string which are substituted, and the replacement string are the new characters which are injected in the string. Coming to the replace function, this function is basically used to replace the existing characters of all the occurrences. So the syntax for this particular function is that replace string expression search string replacement string, where every search string in the string expression will be replaced with the replacement string. I hope I'm clear with the stuff function and the replace function. So guys, these were the top 65 questions that could be asked in your interviews. So guys, if you've attended any interviews and you've been asked questions related to SQL, please do let us know in the comments section if you have any doubts related to them so that we clarify it for you guys. So guys, that's an end from my side today. I hope you've gone through all the 65 questions and you've understood what kind of questions can be asked in your interviews. So if you're preparing for an interview, all the best for your interviews. So thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!